So day 3 of 5.2 was on simplifying radicals when there was a radical in the denominator. So we say that we need to rationalize the denominator. So that's the thing, you cannot leave a square root, cubed root, any kind of root in the denominator. So when you looked at day 3, all of those front problems on the first page all had numbers that we needed to rationalize the denominators. And then you got into about 4 problems, 13 through 16, where you had variables there as well. And then the last 4 were where we had to multiply by conjugates. So there's really 3 things. The last part, multiplying by conjugates, and we'll talk about that. When there's variables involved, what that means, and then rationalizing with numbers. All right, so when we look at those 3 things of what we need to do in day 3, I'm going to start first with variables, and then maybe I'll do numbers and conjugates. So let's talk about rationalizing the denominator when there's a variable involved. So if I have something like 1 over the cubed root of x. So to rationalize that, to get that radical out of the denominator, I have to multiply by something to make that a perfect cube root. So here's really what you're thinking about. You're thinking about it in exponential form. This is really x to the 1/3 power. So I need to get that to be an integer. So if I have 1 divided by 3, that doesn't go in there evenly. If I multiply by another 1, I'd have 2 over 3. That doesn't go in there evenly, but 3 over 3 does. So to get it to be x to the first, to the 3/3, I need to multiply by x to the 2/3 power. Because now I keep the base, when I add those exponents, I'm going to get x to an integer power. So we're always trying to get this to be something where I take this over the root, the exponent over the root. I want that to come out evenly. So whether you think of it exponentially or in radical form doesn't matter. We know that we need to multiply by the cubed root of x squared. So that now when I multiply those together, I'm going to have the cubed root of x to the 3rd. And x to the 3rd is a perfect cubed root. Whatever I do the denominator, I have to do the numerator. And so I'm going to get the cubed root of x squared on top, because I'm just multiplying it by 1. In the denominator, I get the cubed root of x to the 3rd. And again, when we put that back into exponential, it's x to the 3 over 3 power, which means it's x to the 1st power. And there is my simplified answer. So you're always trying to decide what you have, what can you multiply by, so that then those end up multiplying together to get you a perfect root. So let me do another cubed root one. Let's say I have the cubed, 2 over the cubed root of, let's do x to the 5th. Let's just leave it at x to the 5th. And so when I look at that, I have 5 x's multiplied together. I have to think about what can I multiply by? So as I go up, what can I multiply by so that when I take the answer divided by 3, I get an integer. So x to the 6th divided by 3 would come out evenly. So if I've already got 5 of them, I just need to multiply by 1 more of them. Because now I'm going to have the cubed root of x to the 6th in the denominator. So you're really thinking about, I need something that when I take x to the 6th divided by 3, it comes out evenly. So I do the same thing here. Again, I'm just multiplying those 2 together. And down here I get the cubed root of x to the 6th. And the cubed root of x to the 6th, again, is a perfect cube. So all I'm thinking about is putting it back to exponential. X to the 6 over 3 power. 6 divided by 3 is 2. So x squared. Okay? So when you're dealing with exponents and variables, it's really just looking at the number you have and how many more of them do you need, so what do you have to multiply by, so that you end up getting something that's a perfect root. So that if I take 6 divided by that root, I get an integer. So let me just make sure you're okay with, let's do a 4th. Let's say I have the 1 over the 4th root of x to the 1st. Okay, and let's do y to the 2nd. Okay, so now we have 2 terms we have to deal with. We want to multiply by the 4th root of something. This one I have x to the 1st. I have to get it to a multiple of 4. So if I already have one of them, if I multiply by 3 of them, I'll get x to the 4th. That's a multiple of 4. With this one, I have y squared. I need to get to a multiple of 4, so I'm going to multiply by a y squared. That again will get me to y to the 4th. And let's actually even say I have a z to the 10th. What would I have to multiply by in order to get to z to the 4th? I'd have to multiply by a z to the 2nd, because that would get me to z to the 12th, and 12 is a multiple. So just so you see, even if it's over 1, you can, whatever it is, just get to the next multiple of 4. So we'd multiply by z squared. Whatever I multiply the numerator by, denominator by, we multiply the numerator by. So there you go. Multiply straight across in the numerator. In the denominator, we're going to get the 4th root of x to the 4th power. I'll write all this out. X to the 4th. We're going to get y to the 4th. And we're going to get z to the 12th. All right, and then we simplify that denominator. And we're going to keep the numerator the way it is. X to the 3rd, y squared, z to the 2nd, all over. Here we're going to take x to the 4 fourths, that's x to the 1st, y to the 4 fourths, y to the 1st, z to the 12 fourths, that's going to give me z to the 3rd. And there's my answer. Okay, so you're always just taking what you're starting with a variable and raised to a power. You want to decide what you need to multiply it by so that you end up with perfect roots. And to be a perfect root, it just basically has to be a multiple of that root. And this is when we're talking about exponents. All right, when we talk about numbers, so if I have 1 over the cubed root of 2, let's say, now I have to decide what I need to multiply by in order to get that to be a perfect cube. So a couple ways you could do it. You could think of the perfect cubes. 2 to the 3rd is 8, 3 to the 3rd, 4 to the 3rd, and try to find some number you can multiply 2 by to get to one of these. So if I did it that way, I'd say, okay, I'm at 2. I want to get to the cubed root of 8 because that comes out evenly. So I now know I need to multiply by the cubed root of 4. So when I do that, just to show you what happens, in the numerator, cubed root of 4. In the denominator now, I get the cubed root of 8. So your goal is to get one of those numbers so that you can take the cubed root of that number. So if we started with a 2, we could multiply that by 4 to get the cubed root of 8. So that simplifies to 2 in the denominator. Now these do not cancel because that's under a cubed root and that one is not. So those do not simplify. That's as far as you can go with that. Okay, now the other way to do it is to think of what we did with variables. And you could think of cubed root of 2 as 2 to the 1/3. So if you have 2, just like we had x to the 1/3. So if we have 2 to the 1/3, what do we have to multiply by? We have to multiply by 2 to the 2/3 in order to get that to be 2 to the 1st power. And 2 to the 2/3 really means I'm taking the cubed root of 2 squared. Remember, that's what that means. It's the cubed root of 2 squared. Well, that's the cubed root of 4, and that's what we multiplied by up there. So if you want to think of it this way, you certainly may. If you want to think of it this way, with radicals, it's fine. So let's do a square root. If I had 1 over the square root of 5, all right, now I'm thinking of perfect squares. Well, 2 squared, 3 squared, 4 squared, 5 squared. I can multiply by 5 to get to 25. So then I just have to multiply by the square root of 5 over the square root of 5. And with radicals, it's a little bit, or square roots, it's a little bit easier. Because remember, this is square root of 25, which is 5. When you have square roots, it's easier because really all you're doing is multiplying by whatever that is. That's, anything times itself like this. The square root of 5 times the square root of 5 is going to be 5 because it's the square root of 25. So square roots, it seems to me, are a little bit easier because you can just multiply by whatever that is. Multiply it by itself and do the same thing to the numerator to get a radical. Now if there's a number with it, like 1 over 2 radical 3, let's say, now all you really need to get rid of is that radical 3, that square root of 3. So you can multiply by the square root of 3 over the square root of 3. You can ignore the 2. It's only this that you need to get rid of. And so I'm going to get the square root of 3 over 2 times the square root of 9 when I put them together. The square root of 9 is 3. So 2 times 3 in the denominator is 6. So I get the square root of 3 over 6. All right, and then the last kind, real quick, is just conjugates. So if you have 1 over 2 plus the square root of 5, when you have two terms like this, in order to get rid of that radical, we need to multiply by the conjugate. So we're going to multiply by the conjugate, which is just the same terms, except for whatever the sign is in between them, it's going to change the opposite sign. So if I have 2 plus square root of 5, I need to multiply by 2 minus the square root of 5. So conjugate is same two terms, just whatever the sign is in between them changes to the opposite sign. So in the numerator, I just take 1 times 2 minus radical 5, so that stays the same. In the denominator, we have to FOIL, because there's two binomials, so we have to take 2 times 2. Now, the nice part about conjugates is for the inner product, I'm going to get 2 radical 5. For the outer product, because there's a minus here, I'm going to get negative 2 radical 5. They're always going to go away. They're going to cancel out. So I'll have a positive 2 square root of 5 and a negative 2 square root of 5 because they're conjugates. So really you don't even have to write those down because they'll always go away. Then we also have to do the last terms, a positive square root of 5 and a negative 1 times the square root of 5. A negative times a positive is a negative, and square root of 5 times square root of 5 is the square root of 25. Square root of 25 is 5. So I really have 2 minus the square root of 5 over 4 minus 5. Sorry about that. 4 minus 5 is negative 1. So 2 minus square root of 5 over negative 1. And if you want to distribute that, since it's just negative 1, you could write it as negative 2 plus the square root of 5. You wouldn't have to. If you leave it like this, that's okay. You can leave it like that. But that's if you have a conjugate. So if you have a conjugate, you just, or if you have a binomial in the denominator, so there's two terms here, you have to multiply by the conjugate. And so in the numerator we did that. In the denominator, the inner and outer product cancels out, and then just simplify that radical, whatever it is, to get your final answer. Okay, so that is day 3.